it has higher tensile strength and higher modulus of elasticity. So it's really different material, kind of steel, different type of steel. We cannot take the rebar and stress it like this. So,
yeah. Any other questions? No?
I have a question for you regarding the magic formula for holding one piece, big or small. There is a formula for per piece thing. If you use your trucks, your
oh, how much you can put on a truck?
no, I mean if you have a small piece or a large piece.
Oh, yeah. I talk about that a lot with designers because every time you pick up to get precast on a building, you have to have one key thing, and that's a crane. And you have to have a crane that's going to be able to lift the largest piece of precast that you have on that job. So that's kind of going to be the crane that you're going to go with for the whole project. So then every time you pick up a piece off a truck and put it on a building, you're going to pay what we call the pick price. And the pick price is going to be for the use of that crane. So the crane doesn't really care what size it is. You're still going to have to pay. If you're in downtown Chicago, it might be $1,500 every time you pick up a piece and put it on a building. So if you have a 1x10 column cover, you've now added $150 per square foot to put it on the building. So in general, larger pieces are going to be less expensive. You don't want to have a building full of small pieces of precast because you're going to have to pay that pick price. And it also would take longer to erect the building as well.
So these two advices you give, the repetition of the piece, so
right.
you make many of it,
right,
and as large as possible.
Right. In general, larger is going to be less expensive, and then the repetition is going to be important. You saw how everything's cast in a long line bed. You want all of your strands lined up the same way, so piece after piece, the strand pattern will be the same, because every piece has to be engineered for that specific project that you're doing. Even though you're using the same notes on the keyboard, you still have to engineer it or compose it in a different way. So absolutely, you want to create as much repetition and use the same pieces over and over again. And then those are going to be the two biggest factors in the cost of the precast. One is the size of the pieces. The other is the amount of repetition that you have.
Any other questions? I have a question regarding some tips or tricks of trade that they would do for extremely long piece, the longest piece they can have. How do they transport it? Or if it is tall, how do they manipulate it? Or
well, with the longer pieces, like with that, I was talking about that bridge where it was 176 feet, you really start using the piece of precast as kind of the bed of the truck. Then you don't actually have a truck bed. You'll have wheels on the front and then another column of wheels on the back. And then the driver will have a steering component to actually steer the back wheels from the truck or the cab of the truck. So then you'll get it to the ground that way. And then also, as I mentioned, when you're erecting precast, you always want to handle it from the two ends. You never really want to handle it from the middle because it can snap. So the precaster will do all of the engineering, excuse me, all of the engineering for the pieces of precast, because when you handle it, excuse me, that's going to be when the most pressure is actually going to be applied to a piece of precast, not when it's in place in the building. It's all of the handling that goes into it. And so the precaster likes to do all of the engineering of his own pieces and all of the connection details.
Thanks. Now, you gave us your definition for precast. What is the definition for pre-stressed? Pre to what?
The pre-stressed is what uses those pre-stressing steel, and you've got that steel within the piece. So precast is any kind. Pre-stressed concrete is also precast concrete, but precast concrete is not necessarily pre-stressed. Usually pre-stressed concrete are pieces that are longer, that require more load placed on them, or maybe they're structural pieces. But the pre-stressing is what allows you to actually use less of the concrete material without losing any strength, or by gaining strength.
And the pre-term, time-wise, reflects to the pouring of concrete, so you are actually stressing the steel or the strands before
you place the concrete in the
hence the term pre for stressing.
Yeah. Well, you can also do post-tensioning, which is sometimes you see precast done with that. You don't see a whole lot of that done in this area. And they would create a sleeve, the precaster would create a sleeve within the precast product. Then it would go out to the job site and be stressed at the job site and then grouted into place there. So you could get your tension that way without stressing it at the plant. So really it's a function of stressing it at the plant versus stressing it at the job site.
What would make an owner or engineer or architect choose the prestressed precast over other post-tension or other types?
Well, one of it is what's commonly used in your area, but we usually can provide something much faster than other types of products if you were casting something in place. Sometimes it's fire prevention or fire ratings are going to be important. City of Chicago loves concrete because they're real funny about fire. So sometimes it's the needs of the college or the project. Sometimes it's how fast is it going to go up. Sometimes it's what does it look like. But usually it's faster, cheaper, better. The quality of the concrete is going to be a little bit better too, because they're using very low water cement ratio because they want to turn those beds over and start casting the beds again the next day. So that's going to be key.